Good afternoon, and thank you for joining us today for this live talk on International Women in Engineering Day, which many of you will know celebrates and inspires girls and women in engineering careers. The theme for this year is Engineering Heroes, and soon you will hear from ours. Active STEM ambassadors Jo and Michelle will provide you with a personal introduction, followed by an overview of why they chose to pursue careers in engineering and why they still remain passionate and dedicated to the industry. You will have the opportunity to ask them as many questions as you wish, so pop them into the chat and we will do our best to answer as many as we can. However, if we do run out of time, any remaining questions will be sent to Jo and Michelle and we will share their answers with you as soon as possible. You may also email us any questions post-event to askanambassador@canterbury.ac.uk. That's also in the chat for you. So that's enough from me. Let's get on with our live talk. And first to speak is Jo.
Thank you very much, Lisa. So good afternoon. My name is Jo Harnell. I am an assistant civil and tunnelling engineer. And this afternoon, I'd like to give you an insight into my journey into engineering and why I decided to pursue a job as a civil engineer, and also give you an insight into some of the incredible projects that I have been part of. Next slide, please, James. So as mentioned, I'm an assistant civil and tunnelling engineer, and what that means is I work in developing, designing, building and managing and maintaining the critical infrastructure that underpins our lives. That could be the roads, the railways, the water transfer networks, the airports. It's truly diverse. I've had incredible opportunities and experiences, and I've only been in the industry 4.5 years. That was 1.5 years as a student when I was trying to get as much experience as possible and find out what I had a passion for, what made me incredibly interested, what made me feel incredibly satisfied and incredibly proud. And that is tunnelling. And so I've spent the next 3 years in tunnelling, and I currently work as a quality engineer at the Hinkley Point C nuclear power station, which is under construction down in Somerset. Next slide, please, James. So how did I get into engineering? It's a good question. I studied A-levels of biology, chemistry and maths, and they reflect the fact that I was very torn between pursuing a career in medicine or engineering. I really wasn't sure. I did work experience in both, and I loved engineering because for me, engineering enables us to sustain living standards and especially improve living standards in poorer parts of the world. And it links back to something you might have heard about, which is called the UN Sustainability Goals. So how can we make the way that we live for people more safe, higher standards of living, and also more sustainable? So that's why I decided to pursue a career in engineering. I studied a civil engineering degree, a master's, with a year in industry, which is where I found tunnelling, but I'll come on to that a little bit later. And what's been fantastic is, although I am still very early in my career, women really are supported and they really are empowered in this industry. We are in the minority, that's true, but we are supported. And on the side, you can see some of the incredible awards and scholarships that I've already been a recipient of, including the picture, which is I've been named one of the top 50 women in engineering for 2021. So that's me with my trophy, looking very, very proud. Next slide, please, James. So coming back to my projects, what really makes my job get me out of bed in the morning and get me into the workplace quite early for 6:30 in the morning is the projects that I get to work on. You can see on the right hand side there are some fantastic images of what we call a tunnel boring machine, and I've worked alongside these on some incredible projects. And what they do is they drill a little bit like a corkscrew. If you've ever seen someone open a wine bottle, they basically drill through the earth and they construct the tunnels that you may have been on when you were riding on a train or in a car. And some of the projects I'm going to share with you are a combination of all these sorts of different infrastructural projects, but I'll go on to them in a second in a little bit more detail. So next slide, please, James. The first project I worked on was Crossrail. Crossrail is a new east-west running line in London, and it's a new underground line. This is the first project where I identified tunnelling and knew it was amazing. You can see the incredible scale of the tunnels that we're building underneath the ground surface. And the fantastic thing about this is we do it in such a controlled, precise, and highly skilled engineering way that people walking on the ground above don't even know that we're there in the most cases. And on the right-hand side is a demonstration of one of the fantastic stations that we will leave behind once we've finished our works. Next slide, please, James. Next is something called DFMA, and this is an acronym for Design for Manufacture and Assembly. And really what this is an amazing jigsaw. So what we're doing is to try and reduce the impact of construction on everyday people's lives and also on the environment. We're fabricating all the pieces of the jigsaw away from site and we bring them together. So this might be, for example, a residential building, as you can see in the top left-hand image, where effectively all the modules, all the different rooms or apartments are made off-site and they're assembled together. Or it might be such as a bridge on the right-hand side, where again, all the columns and all the bridge decks are made off-site and assembled together. And this makes the project cheaper, it makes it safer for the people working on site, but it also reduces the amount of carbon that's embodied in the project, which is a fantastic achievement. Next slide, please, James. Thank you. The next project is Thames Tideway, and hopefully the impression that you're getting is how vast and incredible some of these projects are. So Thames Tideway is a new super sewer in London, and what you can see in the top left hand is you can see how the sewer is actually being constructed under the river. So we're driving some of these TBMs that I mentioned under the river, sorry, and where we lower them down is some of these incredible shafts that you can see on the right hand side. They're very, very deep. To give you an idea of scale, if you take a double-decker bus and you put 3 of them on top of each other, that's the diameter of the tunnel that we're constructing through the earth following the River Thames. And some of these shafts are about 40 meters wide going down in London. Again, with very few people being disrupted by the works. Next slide, please, James. Another incredible project I was involved in is Heathrow Expansion Project. This time, less tunnelling, but it was for the construction of Heathrow's 3rd runway. You may have heard that that has been delayed, but this was an amazing project because there was a huge emphasis on environmental protection. Yes, we're building a runway and it's fast. It would have required a partial rerouting of the M25, which is a major undertaking. But we were also looking at how can we minimize the impact on the environment? How can we minimize air pollution? So there were some incredible ideas that we came up with in terms of environmental corridors, which meant that animals and invertebrates living nearby could still continue their migratory patterns and also their general habitat movements. So it's also worth considering, although you see these major pieces of infrastructure, there's also an incredible amount of work that goes on behind the scenes to maintain the environment in an as good, if not even better condition than we first found it. Next slide, please, James. South Tees redevelopment is a project that's really close to my heart. On the left-hand side, you can see the current status of South Tees. This was a former steelworks. It covers an area of 1,800 hectares. It's absolutely vast. When the steelworks shut, it was the main employment source of employment in the region, and there was huge unemployment as a result of its closure, and it resulted in the loss of a lot of jobs and also deprivation in the area. But, and this is where engineering can really be a life-changing contribution for a community, South Tees was redeveloping this entire area into an international business park, creating new jobs, also focusing on renewable energy. So, for example, the fabrication of wind turbines to really change and kickstart the economy and the social standards of this area. It's an amazing project. Next slide, please, James. And currently, Hinkley Point C is where I find myself right now. So Hinkley Point C will be the first nuclear power station in the UK for over 30 years, and it will provide 7% of the UK's electricity demand. So it's such an incredible asset for the UK. But what I'm working on is the tunnelling, and what you might be able to spot on the left-hand image is one of those TBMs I mentioned earlier. But on the right-hand side, you can also see an incredible piece of engineering. This is to bring the water, the cooling water that keeps the nuclear reactor cool, out from the reactor after it's done its job of cooling, and it's all clean, and it will take it back slowly into the Bristol Channel. The very, very incredible scale of works, and as you can tell, something I'm very passionate about. Next slide, please, James. So that's hopefully given you a flavour for some of the incredible and absolutely jaw-dropping projects that I work on. But I also work alongside some truly amazing people, some of whom are shown on this slide. My career is incredible. There's nothing short to say. There are so many opportunities. There are so many open doors. There are also so many transferable skills, not only in the industry, but also in terms of I'm a more confident person in my personal life, in terms of having to deal with life issues. I've made some incredible friends, and especially as a woman in the industry, I feel incredibly supported and incredibly privileged to be working in the industry at this time when we are really focusing on diversity and inclusion. But also for me, I have huge job satisfaction because at the end of the day, I get up and go to work and I go home having contributed positively to society. And I really, really would encourage you to think about a career in STEM. Alongside the opportunities to work in incredible projects, there's also the most amazing opportunity to travel around the country and travel around the world and leave a positive impact on the world that you live in. Thank you very much for listening.
Thank you, Jo. That certainly was very informative, and hopefully it has inspired our audience to think further about careers in the engineering industry. And congratulations as well. We can see there are many questions in the chat, so we will put those to you when we have heard from Michelle. So welcome, Michelle. It's over to you.
Thank you, Lisa. Thank you for the warm welcome. Good afternoon, everybody, on International Women in Engineering Day. My name is Michelle Mitchell, and it's a great pleasure to talk to you about engineering, and I hope to inspire some future engineers with my fairly long career so far, and the diversity within it. Next slide, please, James. So, my current role is a quality manager. I am a qualified civil engineer, and I have 32 years of engineering experience. I spent just over 29 years in the highways and transportation sector, and 2.5 years ago I moved to an engine manufacturer, and I now work in their power systems sector. I'm also a STEM ambassador. I have been for quite a long time now, because it really is a passion of mine to inspire the next generation of not only engineers, but anybody who could go into a STEM subject and just show that it is, you know, diverse, and people quite often overlook the STEM subject. So hopefully you might get some inspiration today. Next slide, please, James. So my route into engineering differed slightly to Jo's. I started obviously taking my O-levels, which are GCSEs now, and then I moved on to do A-levels in maths and physics. They were my favourite subjects, quite tough subjects, but I didn't really know what I wanted to do with them. So I looked around and I thought a career in engineering would be really good. So I started on a civil engineering training programme, which you would think today is more like an apprenticeship. So I then went to college as part of my work on a day release to do an ONC and an HNC in civil engineering. So working 4 days a week and 1 day at college during term time. And then when I finished my college, I moved on to take professional qualifications, starting off with joining the Institution of Civil Engineers and qualifying as an incorporated engineer and a member of the Civil Engineers. I've also progressed further and become a member of the Institute of Leadership and Management. You'll find throughout your career you continue to learn and develop, and I took some professional management and leadership qualifications to join that institution. And then more recently I became a practitioner of the Chartered Quality Institute, which relates more to my role today. Throughout my career I've had various continuing professional development opportunities. These are things where you learn new skills, could be soft skills. The way technology changes every day and every year at the moment, it's always really good to keep up with the latest technologies and changes in engineering, because it's gone, if I go back to when I first started, sort of 30 odd years ago, most of the things that we did were actually pen and paper, and now everything is computerized. So during that transition, obviously there's been quite a few courses that have developed those computer skills, and obviously we're using Microsoft Teams today to bring this to you. So that's been another transition. Next slide, please, James. So my career started with Kent County Council, say on this trainee programme. It was kind of, we called it a rotational scheme. So I started in their surveying department, looking at surveys for new roads that were going to be built throughout Kent. And I then progressed on to the design office, where I learned some skills about the design process and how complicated it actually is to design a road or a tunnel or a bridge, etc. It was really interesting. And then I moved into the construction and maintenance side, which is where I actually spent most of my career. And that's where I found it most exciting. During my time with Kent County Council, that's when I became a member of the Institution of Civil Engineers and passed my professional qualifications. So I then moved on to another company called Ringway. They were a construction and maintenance company, and I worked on various projects with them, either constructing new roads or maintaining. One of the main things is that whenever you build something, you still have to maintain it afterwards. You can't just walk away. So maintenance aspect of engineering is really important. And I've worked on some amazing projects to maintain existing infrastructure. So the picture you can see on the top left is actually Ramsgate Harbour Approach Tunnel. So one of my responsibilities was actually looking after the tunnel in terms of maintenance. So we used to run checks on the road surface that run through, make sure there's no concrete cracking in the tunnel itself. Mechanicals, there are fans that extract the exhaust fumes, make sure they're all running correctly. There's fire prevention systems and making sure they are too. We even did a incident response where we actually recreated an accident in the tunnel and how we would respond to evacuate people, close the tunnel, etc. So it's really kind of exciting part of that job. The picture on the right-hand side is actually of the Dartford Crossing. One of the projects I was involved in was resurfacing the Dartford Crossing. I don't think many people ever see it like that, empty of cars. And it was really interesting and quite eerie to be stood on the top of the bridge with very little traffic and just watching everything that was going on. I then moved on to Ringway Jacobs. Ringway Jacobs is a joint venture company between Ringway and Jacobs, which are another international engineering company. And I moved into the world of quality at that point. It'd been a passion that had run through my career so far, and quality is about making sure that process, procedures and policies are implemented and worked to, and checking that everything is fit for purpose. And we are working towards correct specifications and standards. And then back in 2019, I decided that I was going to have a complete career change and a new challenge. And I joined Cummins. Cummins are a global engine manufacturing company. They have a turnover last year of 19.8 billion, and they employ 58,000 employees worldwide. They manufacture engines and generating sets as well, and I work within their project execution team. We take their generating sets and we use them in things like hospitals for backup power, for greenhouses for supplying electricity and combined heat and power. We use them for data centers, so all the places that hold your data for your Snapchat and your Twitter, and obviously Microsoft Teams as well. We provide backup power, so they've got continuous power should they have a power outage as well. The latest projects I'm working on use this wee beastie at the bottom. You can see on the bottom right hand side, this is our engine called the HSK 78. It's a gas engine. It's 78 litres, so when you compare that to the current car that are on the road, they're around 2 litres, so you can imagine how big it is. And if you stood an elephant next to it, the elephant might look a little bit small next to the engine as well. So they really are big, and it's amazing projects to work with those. They're being distributed throughout the world at the moment. Next slide, please, James. So today at Cummings, we celebrated our engineering heroes, and I'd just like to share this short video of some of the inspiring women engineers we have at Cummings to show you that there is lots of different careers in engineering. Could you play the video, please, James? Thank you.
My engineering hero is Edith Clark, a pioneer in electrical engineering who used math to improve our understanding of power transmission. She was the first professionally employed female electrical engineer and the first full-time female professor of electrical engineering in the United States. Her most famous contribution was the Clark calculator in 1921. This was a device that simplified the equations electrical engineers used to understand power lines.
My engineering hero is Nikola Tesla. He developed a system of alternating current which enabled power from Niagara Falls to be transmitted to great distances. The system was put in place on November 15, 1896, when electric power was transmitted from Niagara Falls to Buffalo. I belong to Pakistan, where we have shortage of energy, and during my O-levels, I was motivated to write the research paper on how to overcome the energy shortage. This is when I started reading about Nikola Tesla, and he becomes my inspiration throughout these years to become an electrical engineer.
My engineering hero is my supervisor, Dr. Satsu Ojala, because she is the first female I met who is a leader of a research group in the University of Oulu, Finland, and her work is based on air pollution control.
My engineering hero has been my dedicated to improving plastic surgery. And what inspired me to become an engineer? Since a young age, I've always liked science and maths and finding solutions to problems. So this made me realize I wanted to become an engineer. Growing up, I was always interested in how things worked, and I liked trying to fix things and make them better. My parents were very supportive and bought me Lego and Kinects, and I used to build working roller coaster models with them. I always enjoyed working in teams at school and presenting our ideas and giving problem-solving tasks. As I learned more about engineering, I realised that I enjoyed what engineers did and the opportunities that they had in different career sectors that they worked in.
Well, I have always loved science and have been passionate about saving the environment. So before I graduated to high school, I decided to become an engineer because it's a way to apply science in finding solutions to save the environment. Thank you.
Thank you for watching that. I hope that gives you a little insight into the various women engineers within Cummings. They have all come through different routes to join Cummings. So some have been apprentices, some are placement students, and then have joined Cummings through graduate programs, and some have just joined as a graduate. And I hope that's been inspiring to you and that you'll consider a future in STEM careers. Thank you, Lisa.
Thank you, Michelle, and thank you to both of you for sharing your first-hand experience with such a passion for the industry. So we have got lots of questions, and so we'll take some of those now. So, let's take this one. So we have, this one may be for, yes, this one's for Joe. How amazing that people don't know about tunnelling, cross-tunnel beneath them. So how do you and the engineering team do that?
Lisa, it's a really, really good question. And to be honest, when I first got into tunnelling, I asked the same question myself. But it's because it's a very closely controlled process. I showed you the pictures of some incredible, and they're huge tunnel boring machines, and they're very, very sophisticated bits of equipment. And they can sense everything from the vibration in the ground, the water pressure, the strength of the ground, so the geology, whether it's maybe a clay or a sand or maybe something very hard like granite. And we change the rate at which we drive to make sure that everything is very controlled, steady and stable. And that's how we can progress our tunnels, causing no more than a couple of millimeters movement on ground level, which is undetectable for people above ground.
Thanks very much, Jo. Here's a question for Michelle. Well, it could be for both of you, but let's have Michelle. How has engineering changed over the years? Has there been a change?
Oh, very much so, yes. So when I first started in engineering, it was very much about paper and pens, and we used to do everything by hand. Computers were only just starting to come in, and most of the design work was done by hand. Also, there wasn't mobile phones, so we used to connect with each other either by the phone, or we used to use radio systems, and either things like the personal protective equipment that we wear is now much more tailored to the women, so we can get nice sizes that fit women, whereas you know, when we used to get PPE back in 30 years ago, it was all designed for men, so it looked very big, and I think I was accused once of looking like a walking traffic cone.
Thank you very much. Here's a question to both of you. So if we take Jo first of all, what has been your most challenging project you've worked on?
Without a shadow of a doubt, Heathrow Expansion Project was the most difficult project. It was also the most exciting, the most dynamic, and the most energizing. But it was difficult because it was such a huge scale. There were many different stakeholders, which means there are lots of different people interested in the project, from an environmental, from a legal, from a sort of residential, social, political point of view. So you can see there are lots of people that we have to interface with, which is why being an engineer, if you're very good at talking to people, and if you have good people skills and good at communicating, it really is a fantastic career to pursue.
Thanks very much, Jo. Here's a question which you have probably answered within your presentations, but to both of you, let's take Michelle first of all. What inspired you to become an engineer?
I've always had a love of Lego and K'NEX and Meccano, so I think from an early age I liked constructing and building things. And I remember one year when I was at primary school, I lived near the seafront, and during a winter storm part of the sea wall disappeared, and then during the summer holidays they actually came and reconstructed the sea wall, and I remember spending most of the summer holidays watching what they were doing, from bringing in all the large mechanical equipment, pouring concrete. It really fascinated me, and that probably drew me into pursuing a career in civil engineering, and it also fitted with the subjects that I liked at school as well.
Thanks very much, Michelle. And another question here. Can you explain the routes, if there are different types of routes available into the engineering industry? Jo, would you like to go with that one first of all?
For sure, and it'll be great to hear Michelle's route, because I know it was different to my own. So I went via university. So I did my GCSEs, I picked my A levels. I said that I studied biology, chemistry, and maths. Normally, if you pursue a career, an engineering degree, you study maths and physics. But I wasn't sure, so I kept my options open. But I was still able to pursue a civil engineering degree with maths. I studied at the University of Surrey, where you do a degree. It's a little bit like being at school, but you do a lot more independent learning. And then I entered the industry as a graduate engineer. So that was my route.
That's great. Thank you very much, Jo. And Michelle, over to you.
Yes, so I obviously did my GCSEs and then my A levels in maths and physics. And I didn't go to university, so I actually started on what is now would be considered an apprenticeship scheme, where I was working 4 days a week and attending college on one other day of the week. I attended college for 3 years, and I came out with an HNC in civil engineering, which then allowed me to move forward and pursue professional qualification.
Sounds brilliant. Thank you very much. We have another question here from Eleanor. What advice would you give an A-level student who wants to get some work experience in engineering? Could they get in touch with the Women's Engineering Society? Are there summer programs that they could apply for? Yeah, you probably both can answer that. So Jo, you go for that one, please. Thank you.
I was just going to say it's fantastic, Eleanor, that you're looking for work experience. Absolutely fantastic. I know that the Women's Engineering Society are actually running a campaign at the moment to get work experience. So if you're interested, do head along to their website and sign up. At the moment, with the way things are with COVID, it will be virtual, but that's fantastic because it means that you might have the opportunity to get an insight into a company that's maybe very far away from where you live, but still a very valuable insight. The other thing I would say is, when you're in the industry, you become a lot more aware than when you're sort of looking from the outside. So many companies offer work experience. Send emails, send your CV, try and contact them on social media. There are lots of opportunities out there, so do ask.
Thank you very much. And Michelle?
Yes, I would say get in touch with WES and see what opportunities they have. They'll have lots of opportunities. Also research other institutions like the Institution of Civil Engineers, the Mechanical Engineers, the Electrical Engineers, because they very often have opportunities on their website as well.
Thanks very much, Michelle. And actually, a question just came in regarding how many other types of engineers are there. As we know, it's such a big word, engineering, but covers many, many different areas. So maybe you could talk a little bit more about those.
Yeah, sure. So civil engineer is just the start of it, because when you get into civil engineering, you then branch out into tunnelling like Joe. You may become a transport planner. You may get into bridge construction, or even into marine work with harbours, etc. like that. So there's a broad range of careers within civil engineering, and also likewise with mechanical engineering, electrical engineering. If you look at, say, the Olympic Park, there were hundreds of different types of engineers that worked on the construction of that during its time. And I think if you look at any of those institutions' websites, they'll give you a really good insight into what types of careers are available. Very often starts with a generic type, so say civil, but within civils there are lots of different types of engineer that can move forward.
That's brilliant. Thank you very much. Well, we're conscious of the time now and appreciate that people have to go on to other things. But so we wanted to say thank you so much. You've been absolutely brilliant and very inspiring. We wish you the best in your careers, and we will continue taking the questions, and we'll get back to people after the event. So thank you very much. Thank you everyone for joining us today. We hope you enjoyed it.
Thank you.
Thank you.